Welcome back! So we said earlier that we were going to take a look at the basics of modeling in IDEF0, and here we are. This is going to be our blackboard where we'll sketch out the fundamental constructs of IDEF0 graphical language. First, there's the concept of a function, which is represented by a rectangle. But what really is a function? If you are familiar with, say, activity diagrams in unified modeling language, or business process model and notation, and other flowcharting methods, then you would have heard of the terms process or activity. A function in IDEF0 more or less equates to a process or activity, in other words, a sort of reusable behavior, and in fact, you'll often hear the terms process, activity, and function being used interchangeably. Examples of functions are paint house, learn IDEF0, develop new finance software, prepare sushi, and so on and so forth. The important thing to notice here as a first rule to follow is that these functions have function names that are in the form of active verbs or verb phrases, chiefly because functions are considered as actions whose occurrences typically span over time, which means you cannot have function names like software development, detailed design, reporting requirements, etc. That would be considered incorrect, and to rectify that, you'll have to use verb phrases like develop software, perform detailed design, and gather reporting requirements. So far so good? Nice, let's carry on. Quite early on, we mentioned the terms input, output, mechanism, and control, but we didn't really say what these concepts are, so let's elaborate on this a little. An input can be regarded as a piece of data or information or material flow into a function. It is captured as an arrow with its directionality going into the function and with a bit of text describing what the input means. For example, I always find it easy to refer to the process of cooking something to explain things like inputs, outputs, mechanisms, and controls. So if we considered the function make pizza, then quite crudely put, pizza base would be one such input and pizza topping would be another. These inputs flow into our function. The magic happens there in that rectangular box, and then we get one or more outputs, which means that an output then is a piece of information or material flow out of a function, meaning we have an arrow with the arrowhead pointing outwards. And in our make pizza example, cooked pizza would be one such output. Right. Let's now focus on mechanisms and controls. Mechanisms are, broadly speaking, the means, tools, methods, and assets that support the achievement of a function. In other words, they are elements that allow the execution of a function, and a simple way to think of a mechanism is to think resource. That is, what resource do I have at hand to enable my function to exist? Examples of mechanisms are team roles, specific software tools and systems, consumables, equipment, and so on. Occasionally, mechanisms may also be intangible things like knowledge of how to achieve a function. I've also come across modelers who treat knowledge as input, and that's fine, but from personal experience, I tend to consider knowledge as a mechanism. And when you think about it, knowledge is an asset that is acquired over time and reused to address problems, whereas data and information are things that flow much more easily and readily act as inputs and outputs. In IDEF0, a mechanism is designated by an arrow originating from the bottom of a function and going into it. There's of course a bit of text to say what the arrow means. For instance, if we go back to our make pizza function, one mechanism could be pizza making knowledge as an example of an intangible mechanism, and another could be, say, oven, which is a tangible equipment for baking pizzas. We then have the concept of control, which is another arrow in the opposite direction to the mechanism arrow. In other words, a control feeds from the top of a function, and simply put, a control is something that guides, regulates, or constrains a function. Suitable examples of controls are things like business logic, rules and regulations, legislation, policies, conformance to specific standards, time constraints, programming constraints, process capabilities, system capabilities, material availability, etc. In the area of business analysis, controls sort of roughly equate to non-functional requirements, that is, qualities that a function fulfills. And just to further exemplify the notion of control, for our make pizza function, a possible control could be delivery time and health and safety standards. Great, so that's inputs, outputs, mechanisms and controls covered. Next up is how we create hierarchies of models to capture different levels of detail.